we had gone up to the graphs of trigonometry. All right. So now we're going to continue on with that right now. And we're going to see. And I think I'll give you guys this as homework. I think so, if I'm not wrong.
Yeah.
If I'm not mistaken. Yes.
Yes.
Give you guys this as homework. So we're going to just wait, let me draw it and then you guys have an idea as to how you're supposed to draw it. So the transformation was the graph was y is equal to 1 minus cos 2x. All right, three types of transformations would have been you would have utilized in this graph. And I'm just going to copy down the above axes in order to better to save us some time. All right. All right. So now what's going to happen is that your graph is what you may call it's of technically your usual graph is y is equal to cos x. That is what we've studied. But this graph right here says 1 minus cos 2x. So first of all, I can simply write this down as, in order to make it a bit more easier to understand, I can write it down as y is equal to minus cos 2x plus 1. Because usually we are, we're more accustomed to seeing the variable beginning the equation or at the beginning of the equation. Keeping this in mind, now we're going to move forward with and see what you may call the graph. So now your graph should be equal to, what should it be equal to? Your graph is obviously going to, okay, let's try and draw the original one first. So if my graph was just y is equal to cos x, how would it have looked like? It would have simply looked like this, the above one. I'll just replicate it over here. And 90 to 0, 90 to 1, 0. All right. And then just simply we're going to be replicating it again and again and again. A little talent, but now this would have been your original y is equal to cos x graph, more or less. Does not go above 1, stays during this and everything. Now, your graph, the one that you want to draw, it says minus first of all, and it also says 2x. That means something was just adding on to x. Now, if you guys remember when we did um Transformations. I told you that if something was multiplying with x alone, it increases or decreases the frequency of the curve. So if something is multiplying with x, it's supposed to affect the frequency of the curve. Okay, how so is the frequency going to be affected now? That before you were having one singular wave from, you can say, over here till 360. Now you're going to have two waves. And also the graph is going to be, first off, it says +1 over here. So technically the entire graph should be lifted above. Secondly, it says minus as well. So the graph is going to be what you may call reflected. And where is it reflected? Where is it going to be reflected? We will see that over here as well. That whenever there is a minus sign with on the outside, it's reflection in the x-axis. So there are three types of transformations happening to the graph. One transformation, we can, try and color code them as well. So you have y is equal to minus cos x. Then you have y is equal to what you may call cos x plus 1. These three separate transformations. And you have y is also equal to cos 2x. And you're supposed to combine them. So if I just give you guys a blueprint of how the graph should be, it is going to be the entire graph should be like this. Mhm. So, hmm, because the pink line is showing what how the graph would have looked like if it were, for example, um, if it were only being reflected. So the graph would have looked like this for sure. Clear? Similarly, if it had been only adding up, like if the graph had been cos x plus 1, you would have just lifted the graph one step above. So the entire graph is going to be lifted above. And how do we lift the graph above? Yes, you're going to have to draw the entire graph above. So you're going to, what was beginning from 0 is now going to begin like this. All right, so it was going to be more or less like this, and then just simply drawing waves and waves of each other. So then it's going to be like this, almost on point. And then the entire graph would have been like this if it had just been, adding up. Now you have to sort of like add up all these graphs, but wait, we're just forgetting one, the 2x one. Now that is the most weirder out of all of them. What is that going to do is that your graph is going to, first of all, your graph is two waves are going to occur. So for example, if this is one wave, the graph is going to be like what you may call The graph, okay. The graph is going to look like this. Almost like this. The frequency of the graph is going to increase. Wait, wait, I've drawn this out slightly wrong. So it should be um, two waves, yes. One wave should be like this now. I'm not wrong. Yeah. Wait, just give me a moment. So it's going to be like this. Mm-hmm. Wait, this is getting a bit too crowded. Wait, let me perfect this. So your graph should be exactly like your original graph, but it should happen twice as much. All right. So, for example, if this is one complete wave, the other graph should be able to, make at least two waves. Is this clear, guys? Anyone who does not understand this, let me know. No full
Yeah.
All right. So if we were to draw our final rendition of the graph, that is the actual one, I'm going to make all of them equal to one another. So what is that going to do? That first of all, the graph should go up high. It should be like this, and its frequency is going to be higher as well. So my graph is going to be like this. The red one is the one that we're going to be following. And this is how your graph should be. Is this clear, guys?
Yes, sir.
Hmm.
Yes, sir. It's clear.
So, and if we try to, all right, the one that I'm supposedly trying to highlight is going to be your graph, the transformed one. Hmm. All right, so that is how it was going to be. Anyone who has any issues with these? Now, technically, there
No,
were
sir.
three transformations that were going on. All right, okay. Now, where were we? Once we were done with this, now we can move on to a few quadrant solving. So, and this is all like really, really basic stuff that we have already done since what you may call IGCSEs. So this is not something that is difficult. We start off with 0, we move up to 90, we go down to 180 to 70, and a complete rotation ends at 360. Now, the first quadrant is where if theta lies between any of these, you may call if theta lies between 0 to 90 degrees. For that theta, sine theta, cos theta, and tan theta will all be positive. Clear? Now, if, for example, your theta lies between 90 and 180 degrees, only your sine theta is positive. Both the rest, your tan theta and your cos theta, are going to give you negative answers. Lastly, if theta lies between 180 and 270, apart from tan, everything else will be negative. So you're going to have sine theta, cos theta, which are both going to be negative. They're going to give you negative answers. And tan theta, on the other hand, is going to be positive. And lastly, in a complete rotational, you're going to have, if theta lies over here, only cos will be what you may call positive. Both sine theta and tan theta are going to be negative. Whereas cos theta is positive. Is this clear, guys? Anyone who does not understand this? This is like very basic, by the way. Similarly, a lot of students, I don't know why they get confused when the reverse happens. So if this is 0, then this can be also minus 90 as well, minus 180, minus 270. Therefore, you can also get what you may call minus 360 over here as well. All right, so that can be the case too. So it doesn't really matter. The quadrants are going to remain the same. So we usually write them as all A for all, then sine, tan, cos. And usually a lot of acronyms and these abbreviations have been created using for these guys, such as A for all, and then S for all students take coffee, or all students take care, or stuff of that sort. You can make your own. All right. It's up to your imagination. So we already know this from our previous classes as well. Now, what happens if we've seen above that what happens when theta is a negative number? Oh, when theta is an acute angle. Let's just say that. So when theta is an acute angle, and by acute angle, what do we mean? Something between 0 and 90. So it's not a right angle triangle. Something which is less than 90, greater than 0. That says what an acute angle is supposed to be. So if theta is an acute angle, then you have a few properties that you need to know. Sine theta, sine 90 minus theta is going to be equal to cos theta. So theta of that angle, if theta lies between 0 and 90, if you try to calculate sine of 90 minus theta, that is equal to the value of cos of the original theta. All right, you can even test it out on your calculator. Very simple. Similarly, if it says cos 90 minus theta, that will be equal to sine theta. And lastly, if it says tan 90 minus theta, well, that is slightly different. It means 1 over tan theta. Is this clear, guys? Anyone who doesn't understand this? These are all previous properties that we have done, so it's not something very new. And lastly, when theta, wait, I can just copy this down. When theta is an acute angle, but what sort of acute angle are we talking about? We are talking about a negative acute angle. When theta is a negative acute angle, what happens then is that simply you're going to have, if it's sine of negative theta, just give me a moment, guys. All right, so if you have sine of negative theta, that is going to be equal to negative sine theta. Why? Because a negative acute angle lies in the fourth quadrant. So it's going to remain as such. Clear? Also, and what's going to happen is that all the others will be same. Like for example, cos negative theta is going to turn as cos theta. But an acute angle, that is why I wrote the opposite as well, so that you guys know how we're supposed to, or how we're getting the anti-clockwise movement as well. Okay, but this is something that you guys can figure out as well. Wait, let me give you an example other than this. So what happens when you do 180 minus theta? Sine 180 minus theta is equal to sine theta of the original angle. Then if you're doing cos 180 minus theta, that is going to give you negative cos theta. Because now this time around theta is still an acute angle. Okay, do not think that theta has changed or something. We're just subtracting it from different things. And lastly, if it's 180 minus theta, that is going to be equal to negative tan theta. Is this clear, guys? Anyone who does not understand this, let me know.
No, I'm sorry, I got it.
Nofal, what about you with this way?
Same here, sir. Clear.
Now you guys need to know a few exact values. Now I know that these exact values are available on your calculators as well, but your examiner wants you to know them. All right. So we're also going to, in this table that I'm about to draw is going to be an exact value table. What are those? We'll see. So exact values are really useful, and you're going to use a lot of them in trigonometry as well. So we'll see. I just need to make so it's going to be 10 columns I need to make. So the first one can be the smallest. Mhm. All right. So now what you're going to have is you're going to have values of theta. All right. Theta can be 0, 30. I'm going to write the more generic ones from which you guys are usually asked about. 60, 90, 120, 135, 150, and usually we end it at 180. All right, that last column came to be of absolutely no use. Now you're going to do is you're going to have different values of sine, cos, tan. And what are those values going to be? Sine of 0 is 0. Cos for cos, it's 1. For tan, it is 0 again. For sine 30, the answer is 1 over 2. Cos is under root 2 over 2. And tan is under root 3 over 3. Now, this is the answer that is going to be in your calculator. Your calculator, if you check it, is supposed to give you this answer. But technically, this is not the actual answer. Why? Let's see. So, under root 3 over 3 is actually a rationalized version of your answer, which is 1 over under root 3. I believe you guys remember how we used to rationalize stuff and back in IGCSE, certs and rationalization. So this is just a rationalized version of what you may call this. Clear? So that is what I've written. Okay. Sine 45 is again. Now this is what I like about this. Now the values are going to repeat. Sine 45 is under root this. Cos 45 is going to be half. No. Cos 45. Oh, sorry. Cos 45 is not going to be half. Cos 45 is also going to have the same answer. Apologies. And tan is going to go 1. Now you'll see a wave forming. Now, how will the wave form? Now, cos is going to have 1 by 2. Uh, tan is going to have. Wait. It should be under root 3 by 2. Apologies. Yes, under root 3 by 2. And it's going to be equal to this right over here. Then I don't know why I wrote it under root 2 by 2. Then what's going to happen? Tan is going to have the weirdest answers. So it's going to be under root 3. Then what you're going to have is that you're going to have at 90, we already know. Sine is 1. This is 0. Infinity. What sort of infinity? Positive infinity. All right. We don't really care about the positive and negative when it comes to infinity in this regard, but still you guys should know. Then again, values will repeat. It's supposed to be a wave. Under root 3 over 2 or 120. But now values will repeat for each and every one of them. The only difference it's going to have is that only sine values will be positive. Why? Because after 90, we went into the second quadrant. So now sine of 150 is 1 over 2. And sine of 0 is this clear? Similarly, what's going to happen is that you're going to have values repeating themselves. And you're going to have 1 again. But the most major difference this time around is going to be negative 1 over 2, negative 2 over 3, negative, negative. Clear? And lastly, you're going to have tan as well. It's a wave, nonetheless. But now you're going to again have negative. And you're going to have negative, negative, and lastly, 0. Is this clear, guys? Is there anyone who does not get this at all?
No, sir, I get it.
Right. And 1 pi radian, 180 degrees is actually interchangeable to 1 pi radian. So you guys need to know that too. All right. We written this down, guys. No fun. Any issues?
No, sir, I'm writing.
All right. Let me know when you've written down. Just give me a moment. Let me drink water. All right, guys, done.
Yes, Yes, sir.
Now we're going to look into, we've gone through the graphs, we've gone through how the initial trigonometry was. We've also gone through each and everything. Now what we're going to be concerned with is the types of questions that actually come. Because whatever we've studied up to this point has already been taught to you, more or less. It's kind of like just revision of what you've already studied. Now, what we're going to look into is that we're going to see what type of questions do the examiner asks, because the what you may call trigonometry is such a chapter in which there is not a lot of variation. The examiner is always going to ask you two types of questions. Technically, it's always going to be one trigonometric question. And this is when I'm talking about if a question is only of trigonometry. Obviously, you can pair it up with what you may call your differentiation, integration, whatever, but that's different. This time around, he is just going to be concerned with if it's a purely trigonometric question, question one, like one part of the question, usually the first part is going to be proving the identity. So you're going to be given two sort of like half equations together, and you have to prove that one can become the other. So they'll put two equations equal together. You'll have to prove that one can become the other by using your different trigonometric identities. Clear? So, and this question is usually these type of questions are from ranging from 3 to 6 mark. And a 6 marker is very rare, very rare. So it's usually around that 3, 4 mark range. Secondly, he asks you to solve the identity. Whatever he has told you to prove, now he's going to solve the identity, which is in fact technically a trigonometric equation. So now what's going to happen is that you're going to have, and this one's a major market, so 4 to 8 marks, where 4 ones are, not that much popular. Usually 5, 6 marker are popular in this type of scenario. So he's going to, uh, mark you higher on this one because this is obviously a bit more steps than the first one as well. Also, a lot of students think that usually this is part A of the question and this is part B of the question. Usually that is the case. Now, a lot of students think that if they cannot prove the identity, they leave the second part as well, which is absolutely wrong. The second part is, though he says in the second part, solve the identity, it is still a trigonometric equation that you can easily solve. So the first two parts are not entirely related. They are a succession of each other. Like one part is after the other part, but they're not something like, for example, they're not as if like if you cannot solve one, the other cannot be solved. No, that is very rare. That usually never happens. All right. So make sure that solve the. Usually, I tell my students to solve the equation part first, then go for the other one, because this is what the examiner would want from you as well. Is this clear, guys?
yes, Mr.
All right. Now we're going to look into the identities that are in your syllabus. So there are a couple of identities in your syllabus, which are as follows. So your identity proving is going to be through these identities as well. So let's look into your identities. Now, in total, you have almost four identities, I can say. A few you may even know from your IGCSEs as well. That first off, the most easiest one that I think is this one, where you've got tan theta is equal to sine theta over cos theta. That is the first one. Secondly, then another identity can be or is sine square theta plus cos square theta is equal to 1. Now, with this identity, you can actually make two more. How can I make two more? Is that simply I can write this identity as sine square theta is equal to 1 minus cos square theta. It's the same identity. And this identity can further be written down as cos square theta is equal to 1 minus sine square theta. Now, what do we mean by identities? Technically, what we're trying to say is that somewhere, if it's written tan theta, if it's written somewhere that you're supposed to calculate for tan theta, simply what the examiner, if you cannot further simplify it, you can easily replace tan theta with sine theta over cos theta. Why? Because it is the same thing. It is not different. It's the same possible thing. Is this clear, guys? You need to keep this in mind that your tan theta and your cos theta are going to be what you may call um your sine theta over your cos theta is actually equal to your tan theta. So you can use them interchangeably. Similarly, if it's written somewhere sine square theta plus cos square theta, you can replace it with 1. Or if it's written 1 someplace, you can even replace it with sine square theta and cos square theta. You can do it as such. There is no restriction. It's up to your. I'll always tell my students that identity solving or identity proving is rather what you may call, it's a bit more of a creative job for the student. How is it a creative job for the student? Because it is going to test how much creative the student actually is. It is not something that can be, it's not there like I could give you guys a formula and you will solve it. No, quite the contrary. Because one identity proving question can be solved in multiple ways. And by multiple, I mean a lot of ways. Very different, very different approaches to the identity proving question can be done. In your syllabus till P1, your identities are going to be till here. Is this clear, guys? Is there anyone who does not get this? Let me know.
No, Mr. I get it.
All right. Now we're going to see how do we prove identities. Now there are a few, you can say, steps of doing so. Even though this is highly, you can say, up to the student's creativity as well, but obviously there are a few steps. The first step is, or actually, a rule is that you need to choose your side wisely. Choose the side to be proven, because what they'll do is they'll give you two identities, one which is equal to the other, and they will say prove one to the other. Now you can actually take this one and prove it to this, or you can actually take this one and prove it to this. It doesn't really matter to the exam. That is why I'm saying choose the side to prove wisely. Okay. Try to choose whichever side you think you can prove easily. All right. Secondly, simplification is much more easier than what you may call expansion. So simplification is easier than expansion. You should choose the side which you think is easier to you, but just a slight hint that simplification is always easier than expansion. How do we know that? Imagine something is this big and you're trying to cut it down. That is easier. But imagine going back up to it. That is obviously harder. If I'm given a cake, I can eat it. I can break down the cake. I can rip it to shreds. Now I have small pieces of cake. But what if someone comes and tells me now you from these small pieces of, broken apart pieces of cake, I want you to make the cake again. So I'll have to carefully align the pieces together on top of each other and stuff. So that is much more difficult rather than just breaking down the cake. So simplification is easier than expansion. That is what you guys should know. And secondly, you need to identify the required identities. So identify the required functions needed to be proven. Now, for example, what do I mean with this last one? If you're given something, if you're given a very larger equation and you're trying to prove it to the other, look at the other equation and simply see what is already given to you in the first one as well. Something that does not need to be simplified. Then you can just quietly tick that off. And now go back to the other equation that you're trying to prove it against and see what is required. So see what is required in the second equation, what you're actually trying to prove it to, and leave those things into your equation that you have chosen to prove it to the other one. All right. So make sure that you're following these three steps when you're trying to prove identity. Now, we're going to prove identities in our next class. I'm going to explain all these 3 points in our next class. Until then, as always, we sign off. Bye bye, guys. I'll see you tomorrow. Love.
Bye, Mr. Take care.
Thank you.